During the last few talks that we have been having, we were concerned with utilization of different forms of renewable energy. We will continue the series today with some forms of energy which one can use. One of the forms of energy which has a lot of potential in this country is what is called mini hydro. Hydroelectric power is very well known, and normally what happens is that one collects water and builds a dam at a large height, and then the water flows through a turbine and produces electrical power. The same thing on a small scale is called mini hydro. Mini hydro means lesser water capacity of the dam, lesser height of the dam, a smaller turbine and smaller electrical power generation. The advantage of mini hydro is that it occurs at many places, and for local power generation and meeting the local power needs, it is very ideal. A schematic diagram of such an arrangement can be seen in the visual. As you can see that there is a water dam at a low water head, and the water flows through the turbine and goes through the outlet. In the process, it rotates the turbine blades which are attached to an electrical generator which produces power. Next, we will be considering something which is in widespread use around the world and in our country from times immemorial. Wind has been a source of power for times immemorial. The earliest applications of the winds have been in moving ships across oceans, in small windmills, and later on in electrical power generation. In the next visual, we find that the wind power which is available by incidence on an area A of a given machine is given by half of rho A u cube, where rho is the air density, A is the area of the device, and u is the wind velocity. The efficiency of conversion, which means that out of this energy how much, what fraction gets converted into electricity, is given by 0.59, and that is the maximum value which can occur. We cannot design a wind machine with a higher capacity. Now, one looks at, if one wants to look at the power curve of a wind turbine as it is shown in the next visual, it is clear that the turbine does not start before what we call a cut-in speed. In the figure that we are showing, this cut-in wind speed is 5 meters per second, and then from 5 to 12 meters per second, the output of the machine keeps on increasing as the cube till it reaches a certain value, and then we have a cutout, then we have a rated speed, and therefore, even if the speed increases, we extract the same amount of power. This is to keep the machine simple and beyond damage. At very high velocities of the order of 30 meters per second, we cut the wind machine, which means the wind is not able to move the machine for extracting power. For planning a wind machine or a windmill or a wind generator, it is necessary to know the frequency of wind speeds of a given value. One can see it in the visuals which follow. The visual shows us the percentage of time when the wind speed exceeds a certain value. So, one finds that about 20% of the time the wind speed is above 10 meters per second. This is for a given kind of a distribution. For another kind of distribution, when it changes, the values are different. And now if one is interested to know how much is the percentage of time that we do have the winds occurring, let us say between 8 meters and 10 meters per second, then all one has to do is that this curve that we are seeing below, one has to count the area between 8 and 10, and this gives us the probability of such a machine. This data is absolutely useful in determining the desirability of a wind machine and then checking how good its performance is. Windmill can be used for a number of purposes. The oldest one is water pumping, the second one is electrical power, and the third is of course consumption, that the electrical power has to be consumed. Now, the biggest disadvantage of wind power is that it is sporadic, which means it is not reliable and does not occur at all the time, and therefore, the wind power cannot be used as a standalone system unless the application does not require 100% reliability. For example, if all our aim is to pump water, we do not care whether the machine lies idle for half hour or an hour. We are worried about the total water that is pumped in a given time and what is the cost of doing it. For this we do not need any auxiliary equipment, and an ordinary wind machine should be able to do the trick. However, when we need electrical power on a sustained basis, then certainly it is another situation. And here the electrical power has to be, the wind power has to be used in conjunction with some other power. Normally it is the grid power. So, we have a grid and the wind power is connected to it. As the amount of available wind power increases, the grid power decreases and we consume less of fossil fuel in trying to do so. For villages, one can plan a system where you can combine wind power with either biomass, biogas or even photovoltaic if it is a daytime industrial operation. So, one has to find what is the use, and then one can find out what is the mode in which wind power will be used. The second interesting application we have is that it is known that as we go inside the earth, it gets hotter and hotter. The reason simply being is that the core of the earth consists of molten material at very high temperature and gives out heat. At many places in the world, there are faults which result in steam and hot water coming out of the earth as a geyser. This occurs even at places which are very cold like Newfoundland, Greenland, and there this steam and hot water is immediately useful for heating the buildings as well as for generating electricity through a wind turbine. The hot water is used also for heating the buildings as well as for other uses. At places where there is no natural geothermal energy in form of steam and hot water, what can be done is that we force water on the hot rocks which are below to give out steam, and this gives us steam at a good temperature and pressure which can be used for many purposes. The use of a geothermal energy is either as electricity or as a heat and for refrigeration purposes. There is another exotic device which is being planned, and this is called OTEC. OTEC means ocean thermal energy conversion. In this system, one makes use of the fact that at some depth of the ocean, the temperature is higher than on the surface. Whenever you have two reservoirs of heat at different temperatures, a suitable engine can be worked in or a turbine can work in, which will produce useful mechanical power which can be converted to electrical power. Another interesting thing which can be seen which is akin to OTEC is the phenomenon of streams. You must have all heard about Gulf Stream. That is a stream inside the ocean which runs long distances and warms even the sea in the Arctic Ocean. So, in the stream and outside the stream there is a large temperature difference which can also be utilized as an OTEC kind of a system for generation of power. Another system which is very useful, and at least it has been used at a few places like Rann of Kutch in Gujarat, as well as it is used in Reims in France, is what is called tidal power generation. What is the principle of tidal power generation? The principle of tidal power generation is when there is high tide, the water goes up, when there is low tide, the water comes down. If the water at high tide is stored and brought in stages to the point when the water as it is lowest pass through a turbine, one can generate electrical power. The next visual will make this thing a little clear. We see a basin 1, this basin 1 gets fulfilled or rather filled at high tide when the water level is higher. As the water level is receding, one empties the basin 1 into basin 2 through a turbine. This is during the high tide. Then during the low tide, the basin 2 is left undisturbed, and as the water comes down, you have water flowing from basin 2 to the sea through the turbine, and therefore, it generates power. Thus one sees, and the same thing happens as the water level is rising. Therefore, one finds that one gets variable kind of a power generation during a tidal turbine, but combined with a grid, this can be a useful option. This is something extremely interesting. Another idea which is very interesting is wave energy, because ultimately there is a lot of energy in the waves in the ocean. The water rises through large heights and one would like to make use of it. One thing we have to remember in the wave motion as it is on the surface of the ocean is that the waves travel horizontally while the water moves up and down, and it is this up and down motion of the wave of water which we will try to convert into energy. A schematic diagram for doing this can be seen in the next visual. Kindly take a look at this figure. What we have is there is a rectangular floating platform which you see as a float here, and this platform is floating on the surface of the water, and as the surface of water goes up and down, this platform also goes up and down. It is guided by means of 4 pillars, as you can see, so that it maintains its position. Below these pillars we have flotation tanks, which means there are tanks in which we fill compressed air or just air. The flotation tanks stabilize the platform, which means it does not move around much. Now, what happens is, as this piston moves up and down, it is used to compress air, and that air is filled in the underwater flotation tanks. The compressed air from the flotation tanks moves a turbine which generates electrical power. So, one will see that the flotation tank serves 2 purposes. It stabilizes the system and it stores air which can be used for electrical power generation. You can store it even for longer times, and therefore, guarantee for times when the wave power is not that much and we do not have much of waves. There are other devices for extracting wave power from the in the sea. One is called a tapered channel system or tap chan as it is normally called, and the operation can be easily seen in the next visual. Here we see that there is a reservoir of water which is connected to the sea through what we call a tapered channel. A tapered channel, as you can see, has a variable width, and the height of the tapered channel also varies. So, now you can see that as the sea waves enter into such a system, since their motion is stopped, the potential energy is gained and they rise to very large heights, and this water falls into the reservoir, and the reservoir gets more and more filled as there are more and more waves. From the reservoir we can run a turbine and have the outlet water to the sea, and this will generate electrical power for us. This system is also fairly often used. And lastly, last but not least, we should mention the animal power. Animals have been used for power for a very long time. The largest use which even now exists today is transport. You have bullock carts, you have horse-drawn carriages which are used to transport people, which are also used to transport things, and it is still being used at places where the roads are not very good, or it does not make sense for mechanized transport to run there. One can see in the you are familiar with the old ghani, the oil extraction system, where a bullock moves round and round and it grinds the oil seeds. Another system which you can see which can generate electrical power in the next visual. In this system, by the moving of these horses, one can have a circular motion which can be converted to electrical power in a useful way by using proper circuitry. We have so far, then there is something which is connected to this renewable energy, but not quite, is what we call the waste heat. From the electrical power station, one issues a very large amount of hot water at a very high temperature of something like 70 to 80 degrees centigrade, which can be used to heat the buildings, for distilled water and many purposes. One should be able to use it. Sometimes such a water can be used to preheat the water that goes into the boiler, but that is more a matter of energy conservation rather than renewable energy. In what we have done in the last few lectures is to point out the availability of renewable energy and the uses to which renewable energy can be put. The biggest advantage of renewable energy, as we have seen, is that this does not pollute the atmosphere and this causes least damage to the environment. This is environment friendly, and from all considerations one can use renewable energy. What are the disadvantages with renewable energy? It is not as reliable, it is rather difficult to be able to use, the technology has to be proper, and then we have to find a site specific use. There is nothing like a universal renewable energy use. Where wind occurs, we use wind power, where sun occurs, we use the solar power, where wind occurs, we use the wind power, where waves are there, we use the wave power, where there is biomass, we use the biomass power, and so on. Therefore, if one has to design a strategy for use of renewable energy, one has to first have a resource assessment. which means we go around and find out as to what is the resource which is available there. Like in a way, we have to get the solar data, what is the sunshine, what is the intensity of the sunshine. Then we finally find that what is the wind velocity, how does the wind behave there. Then we find out what is the biomass, what is the animal waste, how much is the municipal waste. We try to gauge all possible sources of power, and of course, we also gauge whether conventional power is available or not. Based on all this and our requirement, which also we have to survey, we try to design a system to match our power requirements using least energy, affecting the environment least, and hopefully with least investment. Thank you.